Hello, welcome back to Learn Physics. In today's topic, we are continuing with our human eye and the colorful world. In that chapter already eye and eye defects over, and in last video we did about the dispersion. Isn't it? What is meant by dispersion, and some other eye defects also we explained, and mainly we finished it till the dispersion portion. Isn't it? So today we are continuing with that chapter from rainbow. How rainbow is forming. Okay, dispersion means, so we should start from, for explaining this rainbow, we should start from dispersion. What is meant by dispersion? When a ray of white light is falling on a prism, it will be dividing it into its component colors, isn't it? It will be like mixture, violet, indigo, blue, green, yellow, orange, red. Like that it will split. That white light will be splitting it into its component colors. So that is called a dispersion. So what is happening in this? So in rainbow also we are seeing all these colors, isn't it? What is the reason for colors in rainbow? Okay, here what are the conditions to get a rainbow? Okay, first one is rainbow will be forming opposite to the direction of rainbow is formed opposite to the direction of sun. Okay, so if sun is behind us, rainbow will be in front of us. Okay, that is the first condition. Then the second one is water droplets should be present in the atmosphere. Water droplets should be there in the atmosphere. Should be there in the atmosphere. Okay, water droplets should be there in the atmosphere. These are the two conditions. So while we are looking at the rainbow, the sun should be behind us. Okay, so that is the first condition. Okay, then water droplets should be there in the atmosphere. So these water droplets will be acting as a prism. Okay, these water droplets will be acting as a prism. So suppose if this is a water droplet, the small water droplet is enough, but while we are drawing we can't draw like that, isn't it? So if the sun rays is falling on this water droplet, it will get dispersed. Okay, and along with the dispersion, here refraction also happening, because these two are two medium. This is air and this will be, yes, water. So first it is refraction is happening, then next dispersion is happening. Okay, then when it is incidenting at a particular angle over here, it will be getting reflected. And again it will be getting refracted and will come back over here, and here it will be getting refracted like this, reflected, and it will be falling like this, okay, to the eye. Clear? This is how refraction, dispersion, and next it is reflection will happen. This reflection is called as, so here also the light ray is passing from a denser medium to rarer medium. Then why it is not reflecting over there, refracting over there, instead of reflection, instead of that reflection is happening over there? The reason is, when the ray of light is passing from a denser to a rarer medium, what will happen? Rarer medium, what will happen? The light ray will be moving away from the normal. Okay, like that, while we are increasing our incident angle, what will happen? While we are increasing the incident angle, it will reflect and will come like this, isn't it? So if we are if the light ray is incidenting at an angle greater than this, So at a particular angle it will be reflecting through the surface of separation, and then afterwards if we are increasing the incident ray, it will be reflecting back. Okay, even if the light ray is passing from a denser to a rarer medium, what will happen? The light ray will be incidenting from a denser to rarer medium, it will move away from the normal. But if the angle of incidence is increasing, what will happen? At a particular angle, it will be refracting through the surface of separation. But if we are increasing the angle of incidence more than that, so this it will be, instead of refraction, it will reflect like this. So here it is total internal reflection. So that reflection is called as total internal reflection. That is, when a ray of light is incidenting from a denser to rarer medium itself, what will happen? After a particular angle, the ray will be reflecting back to the same medium itself. So this angle, when it is refracted ray, when it is passing through the surface of separation, that angle is called as critical angle. So, if the ray of light is falling greater than critical angle, what will happen? The light ray will be reflecting back to the denser medium itself. So, we can see the rainbow over here. That is the reason in all the when the light ray is falling from one medium to another. See, when a light ray is falling on this water droplet, every time we won't be getting this rainbow, isn't it? What is the reason? Because every time the total internal reflection won't happen, because the light ray should incident at an angle greater than critical angle. So that is why it is a very rare phenomena which is occurring over there. Not only at the time of rain. Okay, if water sprayer is there, so sometimes we can observe in water sprayer also we can observe this rainbow over the rainbow colors. Rainbow colors, why it is observing? Because of this reason. The ray is incidenting from a denser medium to rarer medium. What will happen? It will be reflecting from and it is greater than the critical angle. It will be moving away towards the same medium itself. So here the denser medium and towards the rarer medium. So what will happen? The ray is incidenting like this. Clear? So here in rainbow, what are the conditions we should remember? Rainbow will be forming opposite to the direction of sun. Okay, second one is water droplet should be there in the atmosphere. Okay, so when what and all phenomena are happening in the case of rainbow, it is the refraction is happening, dispersion is happening, total internal reflection is happening. These are the phenomena which is happening in the case of rainbow. Okay, clear? Next we are going to study about atmospheric refraction. Atmospheric refraction. What is meant by atmospheric refraction? Atmospheric refraction means in atmosphere the refraction is happening. Okay. See, atmospheric refraction, what is the speciality of this atmospheric refraction? See, if I am taking a glass prism, the density of the prism won't be changing. It will be same only everywhere, isn't it? But in the case of atmosphere, we know the conditions of the atmospheric conditions will be irregular. So we can't predict when it will be denser and which medium will be rarer and all. If temperature is more, it will become rarer medium. If temperature is less, it will become denser medium. And the dust particles and the many other particles are there, isn't it? And wind also there. Depending on those conditions, what will happen? This refraction will be changing. Density of the medium, that is optical density of the medium will be changing. Okay, so we can't say when it will be denser, when it will be rarer. So in this condition, what kind of refraction is occurring? That refraction is called as atmospheric refraction. Okay. So when it is passing, when the ray of light is passing from denser to rarer medium, what will happen? It will be moving away from the normal, isn't it? Since the atmospheric conditions are changing from one point to another point, that is sometimes it will be rarer, sometimes it will be denser, like that and all it will happen, right? So here we can't predict what will be the situation. In between may be denser or in rarer, then it will be denser, like that it will be changing according to the atmospheric condition. So a wavy effect or the conditions won't be same always. So maybe the light ray will be moving from denser to rarer medium at one place. After some time it will be moving from a rarer to denser medium. So we can't predict that, isn't it? So that condition is called as atmospheric refraction. So that the conditions are not constant. So it will be changing. The path of light ray will be changing in between. A wavy nature will be there for that one. That is called as atmospheric refraction. Okay, so because of this atmospheric refraction only, twinkling of stars will happen. Twinkling of stars. So what is the reason behind twinkling of stars? That is atmospheric refraction. So from the stars, so if this is a star and the light ray from the stars are falling on our eye, then only at that time only we will be observing the star, isn't it? So the light ray will be moving from a denser medium to rarer medium, denser to rarer medium, or rarer to denser. In between it will change, isn't it? Because maybe this time it is denser and then rarer, denser, rarer, like that and all it will be moving. So after some time maybe it will be, while reaching here, it will be from a rarer to denser medium. So it won't be a straight line, it will be moving like this. So but while we are observing from here, what will happen? We will be observing the light ray here. Okay, so we will be observing the star at this position. Okay, so this position is called as apparent position. So that is not the actual position. So but every time whether we are observing the star at that point, no. What will happen? Next time while we are seeing, maybe this light ray will be passing from this point to this point. So when we are observing the light ray, when where it will be seeing the star will be at this position. So this is the apparent position. Okay, so at that time we won't be seeing the star here and all. Okay, we will be seeing at this position. Next time when we are observing the light ray, maybe the light ray will be moving like this. So we will be seeing the star over here. Okay, so the position will be changing. Keep on changing. Why? Because the atmospheric condition is changing. Maybe denser to rarer medium, then rarer to denser medium, like that and all it will be moving. Okay, so that is the reason we are observing so first time actual position will be here. First time we will be seeing the star here. Next time we will be seeing the star here. Next time we will be seeing the star here. So the position of the star is changing continuously. So we will feel it as a twinkling. We will be feeling it over there. It's not an actual twinkling. Okay, clear? So then planets, while we are observing the planets are not twinkling. That twinkling effect is not happening for the planet. What is the reason? See, planet compared to the size of the planet is more. Planet is larger. So what will happen? So if from here some light is falling on over here also some light is falling over here. Okay, so this may be getting over this point and we will feel this point as this point. Okay, so suppose A is the first position which we are seeing, then at the position of A we will be seeing B position. Okay, then at the position of B we will be seeing C position, and A we will be seeing B position. So A and B, B and C, A and C, like that it will be changing. So in effect, all the positions will be nullified. Change of position will be nullifying in the case of planet, since it is very large. So first suppose I will say, see, we are observing the position A. Actual position of B is over here. Actual position of C is over here. Because of atmospheric refraction, first time maybe we will see the B over here, and next C over here, and A over here. Okay, maybe this is an exam line. Next time while we are seeing C will be here, A will be here, B will be here. Like that we will see. So we can't see that any difference over there. Isn't it? It will be, since it is large in size, it is happening over there. But in the case of stars, since the size of the star is very less, that won't happen over here. That is the reason planets are not, we are not feeling planet as twinkling effect in planets. Next is early sunrise and delayed sunset. Early sunrise and delayed sunset. See, suppose this is Earth. We are observing from here. Okay? And this is the horizon. Sun is over here. This is sun. Sun rays will be falling from this is very hot region, rarer medium. Isn't it? From the rarer medium, light ray will be falling over here to this, reflecting and falling on our eyes, isn't it? So the light ray is moving from a rarer to denser medium. Rarer to denser medium, towards the normal it will be. So, but we don't know this refraction is happening over here. We will feel that this will be the sun. Okay, so what is happening? Since the light ray is moving from a rarer to denser medium, what will happen? We will be observing the sun over here even if it is below the horizon. So it is early sunrise. Okay, at the time of sunset also that will be happening, isn't it? Sunset, light ray will be falling from this sun, rarer to denser medium, and it will be observing on the so before that sunrise itself we will be observing the sun, isn't it? So this is the reason all these are due to atmospheric refraction. So is it clear? So I hope all of you understood all those things, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.